All right, let's wrap this up. I can explain the kinetic theory and the relationship between kinetic energy and temperature. What is the kinetic theory? Kinetic theory is the theory that explains how particles respond to energy. It explains how particles respond to energy. It explains how particles respond to energy. There are three tenets, means three basic principles. Three tenets of the kinetic theory. Here they are. Number one, particles are always moving. They're in constant motion. They are in constant motion. Particles are in constant motion. They're always moving. Even when they're standing still, they're moving. They're just vibrating in place. It's called Brownian motion. Number two, the more heat the particles have, the faster they will move. The more heat particles have, the faster they will move. And the opposite of that is when matter loses energy, the particles slow down. So everything is always moving. The hotter they are, the faster they will move. The cooler they are, the slower they will move. Pretty easy? I hope so. Here we go. Kinetic energy goes up, so the temperature will go up, heat goes up, and vice versa. So if the kinetic energy goes down, the heat will go down, the temperature will go down. Which of course begs the question, so what is temperature again? Temperature is the average, the measure of the average kinetic energy. It measures the average amount of heat that an object has. For example, I have set this thermostat to be at 70 degrees. I want this room to be at 70 degrees. If I was to take one of those thermal probes and put it right here next to this vent, it would probably read in the 60s. Why? I want the room to be at 70 degrees. Why is the air coming out of this vent at 60 degrees? How does that make any sense? Actually, that makes a lot of sense in light of this definition. Who can explain that to me? In light of this definition, I want the room to be at 70 degrees. The temperature of the air coming out of that vent is 60 degrees. What is temperature again? The average kinetic energy. Okay. Is everything in this room going to be 72, even though I've set it at 72? No. You people are going to be at 98 degrees, which means all the air around you is going to be close to 98 degrees. The air moves away, it warms up the other air. So because of you, this room would be hotter if 70-degree air. See, what would happen if we were to average 70-degree air with 98-degree air, your 98-degree air? What would be the air temperature? So why does it have to come out 60 degrees? There's another big source of heat in this room. What's the huge source of heat in this room? Okay, the fluorescent lights a little, not a lot, but there is a huge. Listen, what do you hear? Raise your hand. What do you hear? The sound of the projector. You think that projector's not putting out some heat? Yeah. Okay, so why is it that the air conditioner is putting out 60-degree air when I want it to be 70? Titan, trying to average it out. Because if we're putting out heat and the projector's putting out heat, then it's going to have to compensate for that heat by making sure that the air that it's putting out is much colder than it should be.
Temperature is a physical property and the quantitative measure of how hot or cold an object is. Temperature is the result of how fast the particles of a substance are moving. The slower the particles move, the cooler the temperature. The faster the particles move, the warmer the temperature. The standard unit for temperature is degrees Celsius. Temperature is measured using a thermometer. A thermometer is a glass tube with a narrow inner column filled with colored liquid. The liquid expands when heated and rises up the inner column. It stops rising when it is the same temperature as its surroundings. The height of the liquid tells us the temperature of the substance. The outside of the thermometer is marked with lines. These lines are called the scale. The range of a thermometer is the number of degrees from the lowest number on the scale to the highest number. Each line is a division. Some thermometers have numbers corresponding with each line. Too many numbers make the thermometer difficult to read, so most thermometers only have numbers that correspond to some of the divisions.
The fact that many particles exhibit opposing characteristics is very important to us. It's one of the fundamental forces. Okay? Positives are attracted to negatives. Positives repel each other, negatives repel each other. It's one of the basic things you learned probably in elementary school. Okay? These basic principles are going to be very important to us. So let's make sure that we all know what we're talking about. Can we not agree that positive particles are going to be attracted to negative particles? And that positive particles will repel, and that negative particles will repel? Got it? What we will eventually mean, what will it eventually mean when we start considering the composition of the atom, which is next chapter? Atoms themselves are made up of smaller bits of negative and positive particles. Atoms themselves are made up of smaller bits of negative and positive particles. There's an interesting fact